life developed as a vehicle for consciousness.
Stuart Hameroff, welcome to How Light Gets In Festival.
Thank you, Ricky. It's great to be here. I've had a wonderful time.
Retired anesthesiologist and consciousness researcher. What makes your theory of consciousness the best one around?
It's the only one that works, really. Most other theories are based on the brain as a complex computer of simple neurons, what I call cartoon neurons, because they only look at the membrane activity and the synapses, and it's algorithmic and it's at one frequency, like between 0 and 40 hertz roughly. Whereas if you go inside the neuron, you see these microtubules that process information at multiple frequencies. For example, not only hertz, but also kilohertz, 1,000 hertz, megahertz, 1,000,000, gigahertz, 1,000,000,000, and terahertz, 1,000,000,000,000, and even faster. And every 3 orders of magnitude, we see resonance patterns that are very self-similar. So it's like a fractal, or actually a time crystal, is what my colleague Anirban calls them, who discovered all this. So we have all this information processing going on at a deeper level, and other theories treat neurons as simple on-off switches, which is an insult to neurons, because cells like paramecium can swim around, find food, mates, have sex. They're one cell. So to characterize a neuron as a bit, a 1 or a 0, is a tremendous insult to neurons.
So it's more than a computer, a very good computer, or is consciousness non-computational? I think
consciousness itself is non-computable. That was one of the contributions of Roger Penrose. So I spent 20 years studying microtubules and modeling them as information processing devices, like computers, molecular automata we call them. And this increased the information capacity inside the neuron tremendously. So the Singularity folks and others were looking at brain equivalents as 100 billion neurons oscillating at 100 hertz, 1,000 synapses, about 10 to the 16th operations per second for the entire brain. So they were saying, well, when we have a computer that can do 10 to the 16th ops per second, we'll have brain equivalents and consciousness. And I was going around being a pain in their rear end saying, no, there's all this information processing inside. So there's actually 10 to the 16th operations per second per neuron at the microtubule level. And so you'd have to multiply that times 10 to the 11. So you're way underestimating the brain capacity, and therefore your target is way further downstream. And they didn't like that at all, because they wanted to have a brain equivalence then. But then one day somebody said, okay, let's say you're right, and there's all this information processing. How would that explain consciousness? You know, feelings, love, joy, the color pink, all that. And I was kind of stunned and realized that I was a reductionist. And fortunately, that person suggested I read Roger Penrose's book, The Emperor's New Mind, where he argued that consciousness is non-computable, that there was something beyond computation, that non-algorithmic. Because if it's algorithmic, there's no free will, there's no creativity. We're just going to do based on what happened before, and very boring and very limited. And he said, no, at the time, it involves a quantum collapse of the wave function due to quantum gravity connected to the fundamental level of the universe, space-time geometry. And when that happens, it introduces another factor that is kind of like platonic values embedded in the universe. And that's what gives you consciousness. So it's non-computable. It's also much denser information. So I love the book. I didn't understand the quantum very much, but I decided I needed to find out. And but Roger didn't have a mechanism, a structure. He had the mechanism. He did not have the structure. And he needed something on the quantum level, much smaller than neurons. So I wrote to him and suggested microtubules, which he had never heard of. I had written a book about them and many papers, and I sent him some information, and said I was going to be in England for a conference and would be happy to come to Oxford and explain them. And he said, great. He wrote back an old-fashioned mail, postal mail. And so I went and visited him in Oxford, and it was a tremendous day for me. And I did most of the talking. He asked me about microtubules, and I just went on and on and on. He mentioned he was going to a conference in Cambridge with the well-known philosophers Dan Dennett and Pat Churchland about consciousness. And I said, well, I'd love to go to that, but I got to go to this other meeting. So he said, thank you very much. We shook hands, said goodbye, and I was pretty happy. I'd gotten to meet Roger Penrose, and I thought that would be the end of it. But 2 weeks later, I was back in London on my way home, and I had dinner with a friend. He said, "Hey, I went to this conference in Cambridge, and Roger Penrose was talking about you and your stupid microtubules." And I said, "Wow." And that was a thrill. And soon after, I got invited to a meeting in Sweden that he was involved with, and we met. We started to discuss how we could apply his objective reduction, that was the name of his collapse, to the microtubules, and that was the beginning of our theory.
So the objective reduction is the superposition collapse, but from the subject side?
No.
How does it work?
A lot of people, so this is the measurement problem in quantum mechanics. You have superposition, but we don't see superpositions. We see everything in definite states. So how do the multiple possibilities reduce or collapse to definite states? And that's still not really well known. There was a theory, and still is, that an external observer, a conscious observer, looks at the superposition, and that causes the collapse. But that puts consciousness outside of science. It's not an explanation for science, and it doesn't really explain what superposition is. Roger explains superposition, how something can be in multiple states at the same time, as using Einstein's general relativity. Einstein said that large objects like the sun bend spacetime, or were equivalent to curvatures in spacetime, and that could bend light from a distant star, and that was proven by Eddington, and who won the Nobel Prize. Einstein already had his. And Roger applied this curvature to tiny particles, like quantum particles. So we said a quantum particle here would be a tiny curvature this direction. If it's over here, it'd be the other way. And superposition would be curvatures in opposite directions, which are basically a separation in space-time geometry. And if they were to continue, you might imagine that each would form its own universe, which is another theory of collapse called many worlds, where each possibility goes on to form its own universe. But he said the separations were unstable, and after a time t would reduce to one or the other. And that was due to intrinsic property of space-time geometry. And the selection of this one or that one would be neither random nor algorithmic, but include some non-computable factor that was based on platonic values embedded in space-time geometry. So something in the universe was influencing these decisions if you made them consciously, if they were conscious.
And so the platonic form is consciousness?
The platonic form is an influence. You could look at it that way, but I look at it as an influence that's going to decide what you're going to have, what you're going to do. Are you going to do A, B, or C, and you're in superposition, or what you're going to order on a menu, or what you're going to do in your life, or any decision really. And the decision comes down to all the possibilities collapsing to one, and that could be influenced by platonic values. So ideally it would be you do the right thing, you do something good, follow the way of the Tao, divine guidance. You can look at it like that. But basically it's an influence that points you in one direction rather than the other.
Okay, and I've seen that you described yourself as a quantum Buddhist, and you just mentioned the Tao. So I'm wondering, but you mentioned also kind of a desire to remain scientific. And so I'm wondering about this kind of spirituality, this kind of, I mean, it sounds close to idealism, but mixed with the kind of scientific bedrock as well. How do those two kind of interplay for you?
Yeah, well, I think certain spiritual things are going to be shown to be true. It's just that without an explanation, they're not considered science. So if we had an explanation, they could be. So consciousness itself was, when I got into this business over 30 years ago, consciousness, it was taboo, really. And I thought it should be in mainstream science. And as an anesthesiologist, I was studying how anesthesia takes away consciousness. And I still think that's the best way to understand the scientific basis of consciousness, by figuring out how anesthesia works. And it's amazing that anesthesia works on all animals and even plants, and suggesting that they all have some consciousness. And they all act in the same way. We know that because if you can correlate their potency in putting any animal or human to sleep with their solubility in a particular solubility parameter, which is in the brain in what's called non-polar regions. So everybody says the brain is too warm, wet, and noisy, which would prevent quantum events, because they have to, in the laboratory, they're done at absolute zero temperature to avoid decoherence. And the brain is 70% water, the body is 70% water. But within that other 30% are things like proteins and microtubules, within which are aromatic rings like benzene or indole rings. And These are found in psychoactive neurotransmitters and psychedelics, for example, and aromatic amino acids. So there's this environment within the protein buried inside. There's no water. Oil and water don't mix, and these are oil-like molecules. So it's not wet. It is warm, but it's not noisy because the microtubules are oscillating coherently at multiple frequencies. They're kind of like a time crystal. So that gets around the problem of decoherence and allows for consciousness, we think, and also even non-locality. Because if you go, if the collapses occur at a faster frequency, you're going to be smaller than matter in some cases and faster, and so consciousness could exist independently of biology, actually. And I think that goes along with Roger's idea that these proto-conscious events are occurring here, there, and everywhere in the table, in the air. And these events are proto-conscious because any qualia or any experience would be random, disconnected, no memory, no context, no meaning. So they come and they go. Metaphorically, they're kind of like the sounds of musicians tuning their instruments before a symphony, and it's kind of noise, and you hear all the sounds, and then they start to play, and it's music. So that's the difference between proto-conscious noise in the environment and the kind of consciousness we have.
What do you mean by proto-conscious? Sorry.
Proto-conscious would be what happens when collapses occur in the random environment, in the air and the table and so forth. And there would be some qualia, some aspect of experience, much like panpsychists say that everything has some component of experience. But panpsychists attach these qualia to an atom or to a matter in some way. And that's a problem because consciousness is dynamic. I think it's a sequence of events. But Roger put it in the collapse process, which is an event, and then you have a sequence of these events to give you a stream of consciousness, a chain of events. But they're not proto-conscious anymore because they're orchestrated and they have information and context and meaning and memory. Kind of like music as opposed to random noise.
So there's a string of events which leads to consciousness.
Yes.
And in a human body, these events are kind of orchestrated into a coherent structure, but these events are kind of happening randomly everywhere.
They can happen randomly everywhere, but in the brain, in the microtubules, at least in the layer 5 pyramidal cells, where I think consciousness mostly comes from, they're highly orchestrated and organized to give meaningful context, and memories also stored in microtubules, it looks like. So you can have the kind of consciousness we have as a sequence of events, which appears continuous, much like a movie or a video appears continuous, even though it's actually a sequence of frames.
I'm wondering, so how do you prove this theory? And it seems like anesthesia is a method to cut out consciousness, and then you can test physically whether the consciousness is present. But consciousness obviously is famously unobservable, and people do have the experience of being conscious even under anesthetic. So
well,
I guess,
wait a second, hang on.
Does that not happen?
That happens rarely. It's usually pilot error or not excusable necessarily, but no, that's a problem. That's very rare. It can happen, and so in my view, you're right. We can't measure consciousness, but we can measure what goes away when you anesthetize something. So we're looking now at signs of consciousness in simple molecules from extraterrestrial sources, because we think life and consciousness came from space, from these molecules that are made by stars that are the same aromatic rings, the same organic chemistry that's in our brains, are produced by stars, and they're almost everywhere in the universe. The interstellar dust is full of these aromatic rings. We can tell by the fluorescence, and in meteorites that have crashed on Earth, and in probes that go to asteroids, and including the one sent by my colleague Dante Loretta at the University of Arizona to the asteroid Bennu, has brought back material that have organic molecules, polyaromatic rings, which are very, very interesting. And they also have micelles, which could have been the origin of life on Earth. So these aromatics, I think, are the key to life. They're key to consciousness, and their basis of organic chemistry. When I wanted to go to medical school in undergraduate, everybody said, if you want to get to med school, you got to ace organic chemistry. That's all about life. And and I took that as a challenge, and I did pretty well on it. But it's a difficult topic. But it has to do with the pi resonance electron orbitals of these molecules that interact and support quantum effects. So it's basically a quantum medium buried within our proteins.
Okay, so you're measuring what goes away when someone's under anesthetic. You're not measuring the consciousness itself because it's impossible to measure kind of positively. But yeah, as you are mentioning, you wrote an article for the IAI recently called "Consciousness Came Before Life" about this asteroid. And so is the idea that consciousness is fundamental and is kind of offering a driving force, which kind of creates life, creates human life? Sounds a bit like Schopenhauer, actually. He has kind of a will, which is a consciousness, or I would read it as that way, and that kind of is a fundamental driving force. Is it something like that? Can you go into, and the asteroid as well, I'm very fascinated by the extraterrestrial asteroid.
Oh, thank you. So, it's always puzzled me why biology evolved, and all this behavior from simple organisms, actually molecular complexes, then simple organisms, to survive when there's no motivation for them to survive. There's no motivation to do anything really, to survive or avoid being eaten or find a mate or do anything if there's no feelings. Everything we do is based on feelings. Could be hedonistic, altruistic, spiritual, good, so why would these organisms for millions and billions of years before genes or brains even, and even then that doesn't really help, why would they do all this behavior to survive and evolve and change to optimize? What are they optimizing? And so it occurred to me when I began to appreciate Roger's idea that these OR moments, the proto-conscious moments that I described, were actually occurring at that time of the origin of life, roughly 350 million years ago, and they could have been the spark of life. And so I wrote an article in 2017 called "The Quantum Origin of Life: How the Brain Evolved to Feel Good." And I kind of recreated the primordial soup with these polyaromatic aromatic rings, and that they would get together and there would be sufficient number of them to reach the threshold for Roger's objective reduction, and they would start to have these OR moments. They would be basically proto-conscious initially, but some would be pleasurable, and those would be optimized by the system. The molecules would arrange themselves, this is what I suggested, to optimize pleasure. And if it happened, they would want to have it happen again. If something was displeasurable, they would want to avoid that. So that these simple molecular complexes develop to access and optimize pleasure and avoid displeasure, and everything went from there, and here we are.
I mean, it's a fascinating switch in causation that you've done, because lots of people are trying to find the function of consciousness in evolution, but it sounds like you're suggesting that evolution is a function that consciousness is using to get pleasure. That's a fascinating kind of switch.
Yeah, I think in some way consciousness is life developed as a vehicle for consciousness, and here we are. Yeah,
and Roger Penrose's objective reduction as well. Again, another fascinating causal switch of so it's not consciousness that collapses the wave function, but the wave function is causing consciousness. It sounds like it's that flip.
Exactly, it turns it around. It's not that, like you said, consciousness doesn't cause collapse. Collapse causes consciousness, or collapse is consciousness.
Yeah,
and it could be an identity theory. I was David Chalmers kind of tried to trick me and said, "Well, are you saying that consciousness causes collapse or consciousness is collapse?" And I didn't recognize the trick at first, and I realized that what he was saying is, if you say it causes collapse, you could say, well, that's trivial because, if it causes consciousness, breathing causes consciousness. You need breathing. You need a lot of, metabolic stuff. So that wouldn't be that useful. So I bit the bullet and said, okay, consciousness or collapse is consciousness. And so it's an identity theory.
Yeah, I mean, it's not a bad bullet to bite, I don't think. I don't think you lose very much in that.
Right. I'm way out on a limb already.
Yeah, I mean, what would you say to people that ask for kind of proof? How can you prove these quantum interactions are causing consciousness? How is this not just more algorithms, more language, more theory? which is kind of trying to get at something which is so fundamental it's almost prior to theory. We're kind of human beings on a planet talking about something so fundamental to us. How can we get behind consciousness to study it and have an accurate theory of it, do you think?
I think anesthesia is the best way. When we started this, people said, this is impossible, the brain's too warm, wet, and noisy, and so forth. And I explained why that may not be the case due to the nonpolar areas that anesthesia acts in. And so we were in the Templeton program for adversarial collaborations of theories, a number of theories of consciousness, and they poured a bunch of money into it, and they picked 5 theories to test, one of which was ours. And we tried to come, we met with the proponents of IIT, Integrated Information Theory, Giulio Tononi and Christoph Kolk, and tried to come up with a common experiment, which if it went one way would disprove one theory, and if it went the other way would disprove the other. And we couldn't come to a common experiment. I still don't think their theory is testable. And anyway, Templeton gave us money just to do our experiment, which we did, and it worked. Basically, we predicted we would be able to show quantum effects in microtubules at ambient temperature, which was a big step because that hadn't, although it had been shown in photosynthesis, but we want to show it in a microtubule, and it would go away with anesthesia. And so we did experiments on microtubules with tryptophan fluorescence lifetimes, and showed that we get those at ambient temperature. And we added 2 different anesthetics, one a gas and one a soluble agent, and both of them inhibited the quantum effect. So that's the first step, and we've had other evidence for anesthesia acting on microtubules. And my colleague Anirban Bandyopadhyay in Japan has shown coherent resonances every 3 orders of magnitude, which eventually get to quantum if you go fast enough.
Another study came out, ultraviolet light and super radiance from Babak. That came out recently.
Yeah, that's tremendous. That's exactly what we want. It's similar to the study that I just described. And in fact, if super radiance is this quantum state that persists and in a network of tryptophans, which happen to be a geometric array in microtubules. So they were really studying microtubules and centrioles, which are made of microtubules. And they showed both theoretically and experimentally this the super radiance in microtubules at ambient temperature. And the next step would be to show that it goes away with anesthesia.
Okay. Psychedelics are a personal fascination of mine. I've written a lot about kind of the philosophy of them. And you're mentioning on this asteroid, the psychedelic rings. Please explain it to me because I'm very interested.
Okay. Well, first of all, I think if you go back to the quantum vibrations in microtubules at kilohertz, megahertz, gigahertz, terahertz, anesthesia, it seems, slows everything down. And so we hope to, we've shown that to some extent. We want to look at that more. Psychedelics, I would predict, would push it faster. So it would push the system, that is all the microtubules in the brain, or at least the ones relevant to consciousness, to go more faster and more into the quantum realm. So you get non-locality, you get deep interconnections, and you get all the things that are part of the psychedelic experience.
Yeah, I mean, non-locality is an interesting one. Interconnectedness. Loss of self. So you're saying the phenomenology of the psychedelic experience is explained by the kind of quantum collapses in the brain and the speeding up?
I think if you have let's say you go from megahertz to gigahertz, that's 1,000 times faster, just because there's a psychedelic on board, and then you're going to be having 1,000 times more events per second than you would without them. And they would be more quantum and therefore non-local. So everything would be connected throughout the brain, and maybe even outside the brain with other entities that you could entangle with. So that's what I think psychedelics do. And your point was that the psychedelics are all aromatic rings, complex aromatic rings. So the 6 ring, and then the 5 ring, which gives you an indole ring. So serotonin is like that, and most of the psychedelics have the 6 and the 5. And which is also found in tryptophan. And the polyaromatic hydrocarbons that are floating around in space are basically the same sort of thing. They're ring complexes, 4 or 5 rings, might have a 5 and several 6s. and very, very similar to the structure of LSD, MDMA, DMT, and so forth. They all have polyaromatic rings.
If you don't mind me asking this question, have you done those substances, and how has that kind of informed your thinking here?
When I was younger, I went to college in the '60s, Vietnam, psychedelics. So yes, then I had a long career in medicine where I kind of didn't really want to do that. I've now retired. I haven't resumed. I could in the future, but I think for me it was very educational. It was more than educational, but it really made me think, and I think I had a lot of perceptions and appreciations that I probably wouldn't have if I hadn't. And now, of course, psychedelics are in mainstream medicine, treating depression and post-traumatic stress syndrome and all kinds of things. And we run ketamine. I was recently working in the hospital like about a month ago, and my colleagues are running ketamine drips on these depressed people, and it seems to work.
I'm wondering about your kind of own personal consciousness and how your theories have kind of changed your life and your personal consciousness and your own kind of ideas about your mortality, things like that. How has it kind of changed the way you see the world?
As far as mortality, I don't worry about dying. I really don't. One of the possibilities here. Well, let me go back. So around 2000, Pim van Lommel and Peter Fenwick in the UK discovered these near-death experiences and out-of-body experiences and characterized them. And the BBC did a show about them, and they asked them, well, how do you explain this? And they said, we can't. Ask Penrose and Hameroff because they had this crazy idea. So Roger didn't want to touch it. So BBC came to me, and I said, well, what I would say is that it could be that when the blood stops flowing and the quantum information in the microtubules kind of dissipates to the universe at large, space-time geometry, which is where it is anyway, normally between the years, but it could become totally non-local, but would stay entangled as kind of a quantum soul rather than just dissipate. So it would stay together, and it could be that consciousness exists after life, and that the near-death experience, if the patient is revived, it goes back inside, but if it doesn't, we don't know. So it's a possibility for afterlife. I don't claim any evidence for that. I let other people worry about that. But what I think is that until we know that consciousness in the brain is a purely classical event, we cannot exclude non-locality and consciousness outside the brain.
That's fascinating because it kind of it explains the maintenance of individuality, but also the transcendence as well.
Right.
And it explains the kind of non-local connection between the two, which remains, and then you can die, go up, and then come back down.
That's kind of a near-death and out-of-body experience, right? And the unity or the inside the brain due to entanglement and binding, I think, is also very important. But it can also be non-local outside the brain in certain conditions.
Okay, I mean, again, just Schopenhauer came into my mind. He has a quote. It's something like, "When we die, we don't go to sleep. Everything else wakes up." Or rather, it never slept, is what he says, which I think is a beautiful quote.
Yeah.
Stuart Hameroff, pleasure to meet you, and thank you for coming to the festival.
Thank you very much. I enjoyed it.